All right, guys, part 3 of 3.3. Let's get to it. So the only difference is I put an and here instead of an or on number 3. And there's fractions. Lots of them. So if you see a bunch of fractions like that, your job is to find a common denominator between 2, 3, 6, and 5. And if you've forgotten, the basic way to find a common denominator between a bunch of them is to take the biggest one and just start talking about multiples of that. So, 6. Does 6 divide all of these? Not 5. Move on. 12. Does 12 divide all of these? Not 5. Move on. 18. Does 18 divide all of these? Not 5. So basically it looks like we got to divide 5 in order to make this happen. So 6, 12, 18, 24, 30. 30 divides all of these numbers. So what we're going to do is we're going to find a common denominator of 30. So it's going to be this over 30, that over 30, greater than that over 30, and that over 30. At which point you multiply each fraction, both top and bottom, by whatever it took to get the bottom to 30. So like here, 2 times what gives me 30? It's 15. So you're going to take 3x times 15 to get the numerator here. 15 times 3x is 45x. All right, next one. 3 times what gives me 30? It's 10. So yeah, you got negative 2 times 10 is going to be the numerator for that one. Make sense so far? So then 6 times 5 gives me 30, so I'm going to multiply both the top and bottom by 5. That gives me a purple 25 here. And then this is the tricky part. 5 times 6 gives me 30. But I have to multiply the top, the whole thing, by not just 6, but the 6 is going to adopt the negative that was in front of the group. So I'm going to call it negative 6 right there. So sometimes it's safer to just say that this is negative 6 parentheses x minus 4. Because usually when you see it here, you won't make the same mistake of dropping the negative as if you see it up here. So now that everybody's got a common denominator, we can ditch them. So ditch the 30s. 45x minus 20 is greater than 25. At this point, I'm going to distribute, so it's going to be minus 6x plus 24. And then everything on the left is simplified. Everything on the right is not. 25 plus 24 is 49 minus 6x. And now once you've got x term constant, you can move them together side by side. So I'm going to say plus 6x, move it to the left, because you want your x's on the left, plus 20 to the right. So you've got 51x on the left and 69 on the right. Divide both sides by 51. And you're left with, I'll do some calculation work over here. Both 69 and 51 divide 3, believe it or not. So if you divide the top by 3, you get 23. If you divide the bottom by 3, you get 17. And this reduces down to 1 and 6/17. So our solution here is going to be x is greater than 1 and 6/17. So this is a part of my solution set to start with. Yeah. The second one, this one right here, is much simpler. Thank goodness, right? All I got to do is move the x's to the left And there's no more constants to move around. So this is going to be 9x is less than 54. Divide by 9, divide by 9. X is less than 6. So I've got x is less than 6 and x is greater than 1 6/17. So my number line, if you want to use the number line to visualize this, is going to be, here's 0, 1, 2, 3, 4, 5, 6. And then, put at least 1 or 2 negatives on the left. Open circle at 1, and it's not quite halfway. So I'm going to put it right here. It's going to the right. X is less than 6. You're going to put an open circle at 6, and we're going this way. Since it's an and statement, we're going to graph what these two solutions share. They share everything in between those two. So my question is, which of these lives inside of that shared space? How about -2? -2 is out of bounds. How about -17? -17 is way over here out of bounds. How about 0? Out of bounds. 3.2. Finally, we got one. 3.2 is in the shaded region. How about -1 3/4? Nope. You know what? Negative anything doesn't work. Because you're not shaded anywhere left of 0 on the number line. So that negative's gone, and that negative's gone. Oh, wow. Okay, so 3.2 is the only one that actually works. All right. Okay, you guys endured the roughest part of it. Now look at number 5. It's not going to be as rigorous as what you're seeing here. Number 5. It looks weird, but it's a pretty quick fix to figuring this out. It's one solid connected inequality. So you've got 4 is less than 5 minus 3x is less than 15. Okay, so this is a connected compound inequality. And what you need to know is that connected compound inequalities or combination inequalities are always and statements. So here's what's happening. This inequality is stating that 4 is for sure less than 5 minus 3x. Okay? So this single compound inequality is true. -4 is less than 5 minus 3x. But it's also saying at the same time that this single compound inequality is a legitimate one. And 5 minus 3x is less than 15. Technology. So, now it looks like number 2. All you got to do is split it up, make sure you put and between it, because compound connected inequalities or combination inequalities are always and statements, and then solve the two. So, you can solve it without moving the x's to the left right away. I'll show you how to do that. So I could just say, hey, that's a positive 5. You can minus 5 from both sides. -9 is less than 0 minus 3x. You divide both sides by -3. You divide it by a negative, so it flips the direction of the inequality symbol. Negative 9 divided by negative 3 is positive 3, and the x is just x. Now here's what you need to do. You need to rewrite it with x on the left. X is less than 3. So there's part of your solution. The other part, subtract 5 from both sides. Dividing by negative 3 again. Again, divide by a negative 3, flip the symbol. 3, 6, 9, so it's negative 3 and then 1 left over. All right, it's an and statement, so you're graphing the intersection or the combination of the two or what they share. Whatever resonates with you, whatever makes sense to you, clutch onto it and just keep it in your brain forever. So I'm going to draw the number line. We need at least 0. Some positive values, 1, 2, 3, 4. Some negative values, negative 1, negative 2, negative 3, negative 4. And they're both open. So you got an open circle at 3 less than, open circle at negative 3 1/3, greater than, and means what they share. They share everything in between. And there's your solution. Now, here's the interesting thing. A lot of times when it's connected at the beginning, they want you to write it as connected at the end. So what does the solution look like if it's split up, but you would want to connect them? So here's what I'm going to do. I'm going to say x is greater than negative 3 1/3, and x is less than 3. The way in which I can write that as a compound statement is I can literally flip the x with the negative 3 1/3 and then say that this is negative 3 1/3 is less than x. And that same x is less than 3. That's how you'd write it as a compound solution at the end. This would be very helpful if you saw like multiple choice where they say, solve this, but they're only giving you answers that look like that. That's how you do it. All right, guys. Wow, 3 videos for 1 lesson. I know it was kind of taxing, but you guys have 2 days to work through these compound inequalities, and I think you guys can do it if you watch these videos. Thanks.